Hello everybody, and this video I'm going to talk to you about this book, The Selfish Gene. Not the smaller, more finer details about it, just the big stream of it, what this book is about. So this video will be a little short, and basically what this book talks about is we, or living things, are more like the survival machines of genes. And genes are things that replicates itself with no outside helps. The genes are replicators, and these replicators replicate themselves, but some has better strategies to replicate than the others. Then the better strategized replicator I guess grows more in popularity. And the genes like the title of the book, genes act a bit selfish. So what that means is the genes being selfish is basically the genes manipulate the living machines, the creatures. The genes manipulate the creatures to act a little selfish, more for themselves than to the others, because what the genes want to do is want to replicate. And when I'm saying want here, the genes don't really want to replicate, they just happen to replicate. And genes don't have thoughts and stuff. The genes happen to replicate, but if the gene happens to manipulate the living creature to act selfish more for themselves so the living creature can multiply more, then the genes that acted selfish just happens to multiply more. So that way, the genes that the replicators that happen to just the genes that just happen to act selfish multiplies more, and so therefore, it just happens to be that genes act selfish, and also the living creatures manipulated by the genes sometimes look like they are not being selfish and more being kinder to the other creatures, not to themselves, to the other. But those behaviors, if you think about it hard, are selfish too. Like, let's say there's a creature A, and there's a creature B, and there's a creature C, and those creatures are not very kind to each other. They like to fight each other, but now let's say they are not very friendly to each other. They want the other creatures out of this universe, basically. Sorta. So let's imagine A just walking along, but and noticing B coming this way too. They look at each other, but decides not to fight each other, because what can happen is the creature A thinks, if I fight B here, I might lose, or even if I do win, I would have used a lot of my energy for fighting. So if I see the creature C coming this way too and fight again, or C decides to fight with me, I would likely lose. I would be the one out of this universe, out of the game. So the creature A thinks, the B thinks the same thing too, and decides not to fight, be kind to each other. But as I explained, these these sort of friendlinesses are all being sort of selfish just for themselves. It's for themselves, not more to the others. And now, also, the book tells us about a different sort of replicators, not the genes. The author Richard Dawkins calls it memes. Memes. The author defines memes as a thing that is in our brains, like maybe information, music, maybe, or some other things that you can that are in your brain, and you can tell other people about it and stuff. These memes can replicate themselves into other living, well, in this case, humans, or maybe the internet. These memes manipulate the humans to replicate the memes to other people. So, good memes that replicate themselves, good memes that are more likely to spread out to a bunch of people, is likely to succeed and replicate themselves a lot. And bad memes, I guess, that are not very likely to spread out much, gets forgotten and stuff. And from this book, Richard Dawkins defining these replicators as memes, the word meme was made. Well, you know, the meme that you see on the internet, the funny things you see. And that's basically the these are the basic things that the selfish gene is trying to tell you about. Wait, I forgot one thing. Also, there's a thing called kin selection. This book is using kin selection. This book is using the this book is also explaining about kin selection, and this is a thing that William Hamilton wrote as a paper. The kin selection. I'm gonna have to use the board, and basically there is a human, and this human has a let's just call it a creature. This creature has a mother and a father. So, and this creature shares half of its genes. Basically, the genes, basically the number over here, the 1/2, what that means is the likeliness that this person, this creature, will share the same genes with this creature, which is a parent of this creature. So, like, there's two genes that now something like now this creature needs genes, needs the genes of their parents. Well, has genes of their parents, but what happens here is this gene and this gene might be passed on to this creature, like this and that, and or maybe like this and that, or this and that, or this and that, like that. It can be passed on to this creature, but also this can happen too, this gene and this gene. So this creature is getting all the genes from this creature, but also this can happen too, this gene and this gene. So this creature might get all the genes from this parent. And so the likeliness of getting, well, let's think of this parent parent creature first. The likeliness of giving this gene to this creature is, well, 1 over 2, because, well, the first scenario is this, and the scenarios are this and that, or this and that, or this and this. But what can also happen is this and this, or this and that, or this, this and this. So there are 6 things that can happen, but this getting this gene passing on to this creature, there are 3 scenarios of it. So basically it's half, so the probability is 50%, so 1 over 2. This is basically, the number is expressing the probability of the gene passing down. Now this gene over here, this gene has also 3 scenarios out of 6, so also 1 over 2. It's the same. Now it's same for this parent too, this gene and that gene coming down to this person, this creature. So it is 1 over 2 and also 1 over 2. Now let's say this creature has a brother. This brother creature now also gets 50% of the parent's genes. Again, 50% expressing the probability of getting the gene passed down. Now, the likelihood of these brothers to share these genes are 1 over 2, because, well, this gene might, with a probability of 50%, might be passed down to this creature. And also, now let's say this gene has already been passed down to this creature. Now let's see, what's the probability that this creature will have that gene? And the probability of that is, well, of course, 1 over 2, 50% that this creature will have that gene. So for that gene, these two brother creatures have, again, 50% of sharing each other's gene. As you saw on this gene, it's same for every other genes too. So brothers and sisters, well, they're siblings, I guess. Sibling creatures share half of their genes with each other. They share 50% of their genes. They have a 50% probability that they would share the exact same genes with their siblings. And also, now let's think of let's say this parent, because I'm standing here, so let's say this parent has a sibling too. Now, has a sibling, and so this would be 50% also, because it's a sibling. And also there's another parent creature and some other creatures which the creatures that got the genes passed on from these parent creatures. Now, so basically, these are their cousins. Now, because now let's look at how close they are. They are, well, firstly, there's 50%, or 1 over 2 multiplied by 1 over 2. And these are parents, so the probability of the same gene passing down is also 1 over 2. So this multiplied by this equals 1/8. So basically, these guys, for your first cousins, you are close to them as much as 1/8. So there we go. And yeah, you have a 1/8 probability, 12.5 probability that you will share your genes with your cousin. And also now, yeah, kin selection works like this. So now you can work out how close you are to your kin. And this is the thing about how much you are closer to your kin. And the kin selection is something like this. Let's say a creature is riding a boat thingy with their family. And these and now this is the main creature we're going to talk about. And let's say now a big storm breaks out and the boat falls over and stuff. And I mean, not the boat falls over. A big storm breaks out and it fills the boat with water, only a little bit, then the storm stops, but the boat is sinking. Someone has to jump out to save all the others, but now, let's say these are all this creature's cousins. Now, is it worth for the genes for this creature to jump out? Is it, if you think about it, cousins are worth 1/8 for if you think of the genes. So if you think about the genes, there are 5 cousins of him or her, whatever this for it. So it is not worth for it. So it is not worth for it to jump out. Now, but let's say these are their brothers and maybe 2 brothers and 3 cousins maybe, then it is worth it to jump out because you would be saving now 2 brothers, so 1, which is equal to it being just itself, and that plus 3/8. So it would be more than 1. So it would be worth it for this creature to jump out and save its families. And yeah, kin selection works a bit like this. And I think that's basically all that this book is telling you. And this is a really fun book, so I recommend it if you like science and biology and stuff. So I hope you enjoyed this video, and bye.